5.6 is on two shapes. One's called a trapezoid, the other one's called a kite. So we have several different parts to these notes. This will be your first part, and so I'm going to try to fit everything on the screen. We're going to write down this, and then I'll explain in a second. Or actually, I'm going to have you pause it right here so that you can write this down. Go ahead and press the Enter button now. Now that you are back, you've written this down. I'll explain that in a little bit. There is an example, which I'm not going to talk about just yet. This is the second thing that I need you to write down in your notes. Go ahead and press the Enter button now to pause, and when they are done writing it down, press the Enter button again to press play. Now that they have the second blurb down, I believe we only have, yep. This is our third thing that I need you to have the students write them down. This little piece that's right here before I get into the examples. Go ahead and press the Enter button now. Coming back to you. Now that we have that, there is one more thing that's in here. It's a kind of a main idea, but I'm going to talk about that in a little bit. You do not have to write this down. It is on page 312 in your book. So if you want a copy of this picture, which is really good for you, it's on 312. So do not pause for them to write that down. It's not a big deal if they write it down. They should just read it and we'll go through it. So let's go right back to the top and talk about the two different shapes. The first one is a trapezoid. Trapezoids have only one pair of parallel sides. These are not parallelograms. The parallel sides are called the bases. So it doesn't matter that it's going this way, or it could even be a trapezoid that is parallel. These two could be parallel, and that could be very well. These would be the bases, and then the other two pieces are called the legs. What's interesting about trapezoids is that the same side interior angles are supplementary, also known as the consecutive interior angles. They are the ones that form something like a letter C or a bracket. The ones that are parallel to each other, the ones that are touching, are always supplementary. We'll do these ones are parallel to each other. Make a C shape, sometimes a backward C, or even if it's like going this way, then these two are the ones that are supplementary, because the same side interior angles are supplementary. Not all of your problems are going to be, I think half of the problems are regular trapezoid problems, where this side is different from this side and this side is different from this side. But then sometimes you're going to be dealing with problems that are isosceles trapezoids. If it's isosceles, if this is the same as that, it's just like an isosceles triangle, that the opposite angles are also congruent. These are called base angles, and the base angles would also be congruent. They have two congruent legs. And if a trapezoid is isosceles, then its base angles are congruent. And there's one other fact here that you didn't write down, but I should probably mention it. And the diagonals would also be congruent for a isosceles trapezoid. I'm going to put diagonals are also congruent for isosceles trapezoids only. Which brings us to our first example. It says, find the measures of the numbered angles in each isosceles trapezoid. We need to figure out what angle 1 is, angle 2 is, angle 3 is, and so on. And the only way we can solve this is using this word. It tells you it's isosceles. What does that mean? That means that the two legs are congruent to each other. It also tells you that because it's isosceles, these are the same, the two base angles, the ones that are on the same side of the parallel lines, are congruent to each other, which means angle 1 is equal to 105 degrees. These two are going to be the same. It also means that angle 2 and angle 3 are going to be equal to the same number. And these are consecutive interior or same side interior, so they're supplementary. They add to 180. I hope you know that they have to be 75 degrees. For anybody who's trying to figure out the math on it, it's 180 minus 105 to get to 75 degrees, which means these two are congruent to each other as well. Which brings us to our second concept, which is on the trapezoid midsegment theorem. We've talked about midsegments for triangles, and a midsegment was from a midpoint to a midpoint. Same thing here, midpoint to a midpoint. It's a midsegment. Midsegments of a trapezoid go from a midpoint to another midpoint, and they are always parallel to the bases. And they are equal to the average. This is the average of the top and the bottom. That kind of should make sense to you. But most of the math is going to deal with this little formula here. The sum of the bases equals 2 times the midsegment. Other words, the top plus the bottom will equal double the middle. I like to write that down as well because that will help. RA plus TP would equal 2 times that midsegment. If you can imagine taking this top piece and rotating it around until that top piece was like right there, and what you would create is this MN and another MN because that distance would go there, and then this is RA right there. RA plus TP would equal 2 of these MNs. That should kind of like, if you're a visual person, that should make sense to you. We'll do some problems like that. For example, number 5. This is in your textbook. Feel free to do it. They're not equal to each other, but the top plus the bottom equals double the middle. 2 times 3x plus 5 is 6x plus 10. 7x plus 8, putting those together. And subtracting 6x from both sides, I get x. Subtract 8 is 2. X equals 2. Is that what they asked for? Find EF. EF is right here. They are not asking for this. They want you to plug it back in. And since you're honor students, you're going to read the question again and then go 3 times 2 plus 5. 3 times 2 plus 5 is equal to EF. So EF is equal 6 plus 5 is 11. There's our answer. Which brings us to the last shape. The last shape of this whole unit is on kites. And kites is something that honors kids get to learn about, whereas regular Math 2 students do not even get to talk about kites. But a kite is a 4-sided shape that has the 2 top pieces are congruent and the 2 bottom pieces are congruent. It has 2 pairs of consecutive congruent sides, but no opposite sides are congruent, but its diagonals are perpendicular. It's kind of this like middle of the road shape where, let me draw some diagonals here. Boom, 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 boom. From here to here. Do you love that tool? I love it. I love it so much. So straight. Perfect. And it's called a kite because it looks like a kite. I mean, really it does, right? The diagonals are perpendicular. This makes those 90-degree angles. But it's not a rhombus because these are not congruent to each other. It doesn't have 4 congruent sides. It has 2 pairs of consecutive congruent sides. So in a bunch of true, false, or multiple choice questions, if it says anything that deals with, oh, it has 2 pairs of consecutive congruent sides, kites are the only ones that have that. Trying to think, because a square has 4 consecutive congruent sides. So does a rhombus. This has 2 pairs, except no opposite sides are congruent. Keep that in mind. Can't be this and then something else. So in a kite, you are going to have to use isosceles triangles a lot. You're also going to have to use this 90-degree angle a lot as well. Let's look at number 8. Number 8 says figure out what angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle... Oh my gosh, there's 10 angles? Yes, there's 10 angles. But a lot of them are the same. So if I'm trying to figure this one out, the first fact I have to use is that kites' diagonals are perpendicular. That's the easiest one. If they're perpendicular, then you know what angle 1, 2, 3, and 4 are equal to. They are all equal to 90, 90, 90, 90. Boom. 4 answers. The second thing that I could do from there, it has angle 5, but I think that's where we're going to go next. We're going to go angle 5 next, because I could do angle 10, but what I know about these isosceles triangles, when I say isosceles, I'm looking at this guy like this, that these two angles are the same, and since that's 90 and that's 90, what I'm going to know is that this triangle is congruent to that triangle. These two pieces are going to be the same, and these two pieces are going to be the same. So this triangle here is going to be the exact same as this triangle here, only reflected. So I can kind of ignore that, and I can already tell you what angle 5 is going to be. Angle 5. If this is 46, then angle 5 has to be 46 as well. Sorry. The last thing I want to do is ruin a 12-minute recording by choking. So I drink some water. Actually, some tea. Some nice warm tea. It's good. But that's none of my business. Woo! 46. Okay, let's figure out angle 8 and 10. Let's go down here. Angle 8 and angle 10 are going to be the same thing. Let's put that there. And since these three add up to 180 and this is 90, these two are complementary. They add to 90 degrees. So I'm going to do 90 degrees minus 46. Use my calculator for that, which is 44 degrees. Put that there, 44. Put that there, 44. And then what do I have left? Okay, I have 6, 7, and 9 left. 6, 7, and 9. What I do not want to do is I do not want to pretend that this is a rhombus. A rhombus is one of the only ones that can bisect and make two congruent angles. You can assume that a kite's spine, from the top of the kite to the bottom of the kite, that will bisect the angles. That is a true statement, but not the wings of the kite. The wings of the kite will not bisect the angles, by the way. So that means if this is 34, angle 6 will be the next one, which will be the same as the 34 degrees. So I'm going to put 34 degrees there. Angle 7 and angle 9 will be the same as each other. 34, 90, and this angle should add up to 180. So these two are complementary. I'm going to do 90 minus 34 on my calculator and get that it has to be 56 degrees. 56. And we found all the angles. A lot of questions in that one. It's crazy. Which brings us to this chart, because what I liked about this chart is that it summarized everything that we've done up until now. We started off with polygons and talked about all different kinds of shapes, and then what we did is we focused in on four-sided shapes. We talked about parallelograms specifically, special parallelograms. And this chart, it shows you that it has to have opposite sides parallel. It also shows you that rectangles have 4 right angles. It shows you rhombus has 4 congruent sides. It shows you that squares have 4 congruent sides and 4 right angles. It also tells you quadrilaterals are just 4-sided shapes. It tells you that trapezoids, it has only 1 pair of parallel sides. Still 4-sided shape, still a quadrilateral. And there's these things called isosceles trapezoids, which are not trapezoids, which are trapezoids, but isosceles are more specific. And then there's these kites that do not have those properties as well. It's kind of like a way for you to organize what you've learned and what you have seen so far. Ways that I like to use this is it shows that each subgroup is always a part of a group above it. A square is always a rectangle because rectangles have 4 right angles. This has 4 right angles. It's always a part of the group above it. A square is always a parallelogram. A parallelogram is always a quadrilateral. It is sometimes the group below it. So sometimes a rectangle is a square, but not always. Rhombus is sometimes a square, but not always. Keep that in mind. A rectangle is never an isosceles trapezoid. Just how it goes. It has to be down one of these little diagonals is how I like to use that chart. And remember, it's on page 312. You do not have to write it down, but I want you to have in your mind the properties of each of these shapes because that's what this unit's about. It's about these shapes mostly. Lastly, determine whether each statement is true or false. Justify your response. 47 says, all squares are rectangles. Are all squares rectangles? Are all squares rectangles? Squares have 4 congruent sides and 4 right angles. Rectangles have to have 4 right angles and be a parallelogram. Squares have to be parallelograms. Rectangles have to be parallelograms. This has to have 4 congruent sides and 4 right angles. Rectangles have 4 right angles. All squares are rectangles, and using this chart, all squares, each subgroup is always a part of the group above it. Squares are always a rectangle. That's just how that works. It's true because they have the 4 right angles. That's how it works. We're going to stop your notes right there, and I'll see you in the next video.